So we are going to learn about rationalizing radicals. So rationalizing radicals. What does it mean to rationalize a radical? Rationalize, in this case, means getting rid of a radical. And this could only happen, or it's possible, when we have radicals either in the numerator or denominator, or both. And anytime we rationalize, it is not possible to always get rid of the radical completely. Because if we try to rationalize the numerator, the denominator might have a radical introduced. If we rationalize the denominator, the numerator might have a radical introduced. So in most cases, it is unlikely that we can rationalize both numerators or numerator and denominator. So here is an example. We want to rationalize the denominator in the sense we want to get rid of the radical that we see in the denominator. So as of now, we have square root of 3 divided by square root of 11. So to rationalize, I'm going to take the denominator. Now I'm going to multiply and divide by the denominator that you just have. So numerator would end up becoming square root of 3 times 11. The denominator would end up becoming square root of 11 squared. The root and the square will get cancelled. So we end up having square root of 33 divided by 11. Now we got rid of the radical that was in the denominator. And as I mentioned, you can see, even though we were able to get rid of the radical in the denominator, we ended up introducing one in the numerator, which is square root of 11. So it is not always possible to rationalize both the numerator and denominator simultaneously. So we want to rationalize the denominator. So we have to multiply by the denominator and divide. So square root of 29 divided by square root of 29. I can combine the numerators and write it as square root of 7 times 29 divided by square root of 29 times square root of 29. That would give me square root of 29 squared. The root and the square will get cancelled. So numerator, I'll have square root of 29 times 7, which is 203, divided by 29. So we want to rationalize the denominator. So we are going to multiply and divide by the radical expression in the denominator. So we will end up having 2 square root of x divided by square root of x times x, which is square root of x squared. The root and the square will get cancelled. So we will simply have 2 square root of x divided by x as the answer. Once again, as I mentioned earlier, if we try to rationalize the denominator, unfortunately, one's going to pop up in the numerator. So in this problem, there was a radical in the denominator. I rationalized it, but it popped up in the numerator when in the answer. So that's just how rationalization works. So we want to rationalize the denominator. So we are going to multiply and divide by the denominator. So 2 square root of xy divided by square root of y times square root of y, which would be square root of y squared. The root and the power would get cancelled. So we'll have 2 square root of xy divided by y. We want to rationalize this denominator. So naturally, one might say, I'm going to multiply and divide by the denominator. So in the denominator, 2 times 2, 4. Square root of x times square root of x squared. The root and the square will get cancelled. So 2 root x divided by 4x is what we have. But then if we simplify, the 2 and the 4 will get cancelled. We'll end up having square root of x over 2x. So the lesson that we have to learn here is if we have a number, we don't have to use that when we rationalize. What do I mean by that? So 1 over 2 root x. I'm just going to multiply and divide by root x. Leave the 2 as is. So I will have root x divided by 2 square root of x times x, x squared. The root and the square will get cancelled. Root x divided by 2x. And you can see that is the exact same answer. So when we have a number in the denominator or in the numerator, we don't have to utilize that number to rationalize. We can just keep it as is. At the end of the day, even by some chance you use that number in rationalization, it will get cancelled when the time comes, just like it happened in the first method, when I rationalized it by multiplying and dividing 2 root x. The 2 and the 4 got cancelled. So even if we did it that way, terms will get cancelled and you will get the same answer. So we looked at rationalizing the denominator. So if we want to rationalize the numerator, the process is exactly the same, with one difference. We simply multiply and divide by the numerator instead of the denominator. So, for example, suppose I want to rationalize the numerator. All I have to do is multiply and divide by the numerator term. So numerator, x times x will be x squared, divided by 2 root x. The root and the square will get cancelled. So we'll simply have x divided by 2 root x. So we rationalize the numerator, but then root x popped up in the denominator. So the process is exactly the same, but a small change that you multiply and divide by the numerator term instead of the denominator. So since we want to rationalize the numerator, we are going to multiply and divide by the numerator, square root of xy divided by square root of xy. Square root of xy times square root of xy would be square root of xy squared. The root and the square will get cancelled. So we will have xy over 4 square root of xy. Oftentimes, one may have to come up with a conjugate to get rid of the radical. This happens if you have a radical expression with 2 terms. It doesn't matter if both of them are numbers, or one is a number, the other is a variable. Both of them are variables or expressions. It doesn't matter. If we have 2 terms and we want to rationalize, we need something called the conjugate, because by multiplying and dividing the conjugate, one can eliminate the radical. In other words, rationalize an expression. So what is the conjugate of square root of x plus 3? So we have a radical expression and a number. So the conjugate here square root of x minus 3. Similar manner, suppose we have 4 minus 3 root x. The conjugate would simply be 4 plus 3 root x. Suppose we have root x plus root y the conjugate would be root x minus root y. So if we have two terms, and if one or both of them are radicals, and we want to rationalize either the numerator or the denominator, we need the conjugate, otherwise we cannot rationalize. If you look at all the previous problems, we did not have two terms. We simply had one term, one radical term. So we easily multiplied and divided by that radical term. But since we have, or if we have two terms, we need a conjugate. So the conjugate of square root of x minus 3 square root of y is square root of x plus 3 square root of y. The conjugate of 11 plus 2 root y would be 11 minus 2 root y. So here are some examples that would need a conjugate. So we'll just start with numbers and then we can introduce a variable. So we have 2 divided by 7 minus root 2. So we want to find the conjugate because we want to rationalize the denominator. So we multiply and divide by the conjugate. So in the numerator, we'll have 2 multiplied by 7 plus root 2. In the denominator, we have a, b. So we have a minus b times a plus b. And we all know what the identity or special identity is. A plus b times a minus b is simply a squared minus b squared. So we would have 7 squared minus square root of 2 squared. So 2 multiplied by 7 plus square root of 2 divided by 49 minus 4. Oops. The root and power would get cancelled, get 2. So 2 times 7 plus root 2 divided by 47. And as you can see, by multiplying and dividing the conjugate, we got rid of the radical in the denominator. Give you a couple of minutes. We have to multiply and divide by the conjugate. So 5 minus root 3 divided by 5 minus root 3. The numerator would simply be 11 times 5 minus root 3 divided by, we have a plus b times a minus b, which simply would turn into a squared minus b squared. So we would have 5 squared minus root 3 squared. So 11 multiplied by 5 minus root 3 divided by 25 minus 3, which is 22. In this case, we can take it one step further and simplify. The 11 and 22 can be reduced. So we would end up having 5 minus root 3 divided by 2. So I just multiply and divide by the conjugate, which is x plus root 3. So we will have x times x plus root 3 divided by, we have a minus b times a plus b, where a is x and b is root 3. So we will end up having a squared minus b squared. So x squared minus root 3 squared. So x times x plus root 3 divided by x squared minus 3. So here is a problem where we want to rationalize the numerator. So 7 root x minus root 11 divided by 13. So you may say, I have two different radicals, so how do I change the sign? It really doesn't matter. So you just change the sign in the middle. So to rationalize, I'm just going to multiply and divide by the numerator. Specifically, the conjugate of the numerator. So in the numerator, we now have a, b, and the factors are a minus b times a plus b, which would simply result in a squared minus b squared divided by 13 times 7 root x plus root 11. So when we square 7, we get 49. The root and the square will get cancelled, so x. The root and the square will get cancelled, so 11. Divided by 13 times 7 root x plus root 11. So I'm going to multiply and divide by the conjugate of the numerator. So square root of x minus 1 divided by square root of x minus 1. So in the numerator, we have a plus b times a minus b, where a is root x, b is 1. So root x squared minus 1 squared divided by square root of x minus 1 times square root of x minus 1. We'll simply have square root of x minus 1 squared. So x minus 1 over square root of x minus 1 squared. Certainly, we can FOIL the denominator and write it as x minus 2 root x plus 1, but it is not necessary. It is better to have the answer in that form, because in mathematics, we always want expressions in terms of factors.